idea still is the same, that when we go into, for example, the ECU-A, then we can see that we have our channel description here, the status, i.e. if it is a digital input or a digital output, and then the ID for the channel and what the description of that channel is, and then the process value. Now you can see this one says Triton and not MPC. This is a new design that is in the test phase. So there are some differences when we're looking at the screen compared to what you have in your installations right now. However, the principle is exactly the same. It is an overview of your input-output channels in the cabinets that you have in your engine room or in your engine control room if you're looking at the EICUs. I can have a look at the ECU-A and B, and you can see that the ECU-A is in control, and here we have the EICU-A in control. If you lose either the ECU-A or the EICU-A, then the control is given directly to the ECU-B or the EICU-B automatically. When the EICU-A and ECU-A come back online, and the control is given back to the A units. Cool. Excuse me. So we can also see here we have the CCUs. Looking in here, we are seeing what sort of input-output channels. Again, exactly the same principle as we have seen with the MPCs. I can see the digital input or the analog input, digital output, and so on and so on. Going into the chief access, so now you can see at the bottom the chief has been shown. I can have a look in my ACU, and I can click on the mode at the top, and then I can see I get a choice of taking into test mode, and this is where we can go in and we can adjust or test signals from the MOP screen, from the MOP computer down to the engine room. So if I was to try and test something here, so now I'm taking into test mode, you'll see that the computer is thinking, and then at some point we will have this in test mode. So now we can see that the ACU1 is in test mode. So then I will be able to find an output signal. So we will look for an output here, and we'll say, okay, we want to go into this channel here. And then you can see now my value is yellow. And then I can click on the value, and then I can adjust whatever value. For example, we can see it's 0 to 24 milliamps. So I'll just put 19, for example, press apply. And then the crew down in the engine room, they will be able to measure with a multimeter on this channel for my proportional valve on our hydraulic pump, our engine-driven pump. They should be able to measure 19 milliamps, thereabouts, depending on, of course, the loss with Ohm's law. Then I can go down to 10 milliamps, press apply, and then they should be able to read 10 milliamps. What we're doing here is we're testing that we have a good circuit from the MOP computer signal being sent down to the connector in the multipurpose controller cabinet of ACU1. If you have 10 milliamps on that plug, then you know that from the MOP computer down to the connection on an MPC, you have a good connection, good circuit. So it is from the connection in the multipurpose controller cabinet further down the line that you'll have to check if you have any issues. Okay, so you can swing through all the way through to whatever you want, as long as you are within the 0 to 24 milliamp range. Please keep in mind that if you are taking a controller, an MPC, into test mode, that the engine should be stationary, as you are taking it offline, so it would reboot. You can see the values disappear. It's going to reboot into a different setup like we've just seen, so we're able to adjust signals, output signals from the MPC. You can only test outputs, you cannot test an input, so you're only able to check what is coming out from the system. Cool. Invalidated channels. If, for example, I have on my hydraulic system a problem with the sensor shown here, 2.2 bar, this one was failing, then what I could do is I could find out where the sensor is being fed from. So where do you think pump number 1 is being controlled by? Where is pump number 1 being controlled by? Engine driven pump number 1.
ACU A.
ACU. Sorry, one more time.
ACU A.
ACU A?
Yeah. Yes.
Okay, so ACU. So this one here.
ACU 1.
ACU 1.
Yeah.
Okay, so if you go to ACU 1, then we will be able to find out where the sensor is being fed to. So we will be looking at this ID tag here, 1204-1. If we go back to the auxiliaries page, 1204-1. So they match correctly. Then we would say, okay, go in here, process value, and because I have chief access, I can invalidate this channel. Now you can see I have invalidated here, and you can see I have an indication of invalidation here on the channel itself. And you can see also in the overview of the controller, this input-output test view, also an invalidation. And if I go to my invalidated inputs, I can see here the one I've just invalidated. If I was to go to now my auxiliary system page, hydraulics, you can see now the system is not showing a value here. And also we have an indication now in the square at the top right hand corner of your MOP screens. Yes? If I was to set valid from here, it would disappear from the list. It would also disappear from here. If I went into my ACU1, you could see no longer it is now no longer invalidated. No indication here or here. And you can see now the value is back in action. Any questions to the invalidated channel? Pretty straightforward. Cool. Network status. Here we're looking at the ArcNet network. Again, keep in mind that this TIU is not on a MPC installation, it is for Triton. However, the principle is exactly the same. You have the observers, so the controllers in your control system that are monitoring each other. What that means is, you can see if we look at ECU A, on network A, it cannot see itself. The same with ACU2 on network B. it cannot see itself. They are not interested in what is going on with themselves. They are monitoring each other. Okay, that's how the system works. And you can see